If ABCD is a square and AB is equal to 6, what is the shaded area? So we know AB is 6 and we want to find this area right here. To first understand this problem, we want to find the radius of the circle. And to do so, we will take the diameter, which is equal to the diagonal of the square, which by the way we know is 6 square root 2. As over here, we form a 45, 45, 90 right triangle. So, since this is the diameter of the circle, we know that half of the diameter is equal to the radius. And using the formula for the area, we can now find the area of the circle. So this would be equal to 18 pi. From here, we want to take the area of the circle and subtract it from the area of the square so that we're only left with these four sectors. So 18 pi minus 6 times 6 is 36. And this would give us four sectors. If we only want one sector or one shaded area, we would have to divide this by 4. And this would give us 9 pi over 2, simplest form of that fraction, minus 9, meaning that our answer is A. If G is the midpoint of CB and the area of square EFGH is 100 centimeters squared, what is the area of square ABCD? So since we know that the midpoint of CB is G, we can go ahead and bisect this segment, meaning that we would have two congruent segments. And so we could deduce so for the rest of the segments. And we know that the area of square EFGH is 100 centimeters squared. So each side would be 10. Now, since we have two congruent legs in a triangle, we know that this would be a 45, 45, 90 special right triangle, and the hypotenuse is equal to s times square root 2, which we know is 10 for all of these four right triangles. So divided by square root 2, and then rationalize, and we would get 5 times the square root of 2 as our leg length. So it would apply for the rest of these legs as well. And so, since we know that this is 5 square root 2, this segment, and that this segment is 5 square root 2, we can go ahead and say that the entire thing is 10 square root 2, and the same for every single side of this square. So since we want to find the area of the square, we simply take 10 times square root 2 times 10 times square root 2, and we get 200 centimeters squared. In quadrilateral ABCD, AD is parallel to BC. So let's mark that AB is parallel to BC. And CD is equal to 1/2 of AB. So let's call CD x, and let's call AB 2x, meaning that CD is 1/2 of AB. What is the measure of angle B? So, since we're given that these two segments are parallel, any right angle, we have enough information to create this new altitude and form a square. And since we know that all sides in a square are congruent, we can go ahead and call this altitude x. So now, we have a new right triangle, and we have 2x, x, so this reminds us of a 30, 60, 90 special right triangle. So if this is 2x and this is x, this segment must be x square root 3. Let's call that point E. So AE is x square root 3, meaning that if this is a 30, 60, 90, the smaller segment would be x, the second longest segment would be 60, and the longest segment, the hypotenuse, would be 90. So since we also have square BCDE, we can go ahead and form this right angle, which is 90 degrees. So in order to get angle ABC, we have to add up angle ABE and angle EBC. So angle EBC, that's 90 degrees, and angle ABE, that's 60 degrees. So 60 plus 90 is equal to 150 degrees.